All right, let's have a look at simplifying terms that have roots, square roots, and powers on the same term. All right, so let's have a look at this first example. The first example is root x squared. Now, the general rule is that when you square something, so multiply a term by itself, and then you're asked to square root that same term, those two functions are the opposite of each other. So squaring and square rooting are the opposite of each other. And so what you're going to end up with is just the final answer is whatever number or letter you have inside that square root. So the square root of x squared is just x, right? The square root of 7 squared is just 7. So whatever term you have, as long as you're squaring something and square rooting something at the same time, it's just going to be that number inside the square root. But why is that the case? Well, if we just have a look, let's use our example with root 7 squared. Let's do that again. What I can do is I can just show you in expanded form what that looks like underneath the brackets, underneath the square roots rather. That's just root 7 times 7, right? That's 7 squared. But if we go ahead and solve that, that's just root 49. And root 49, well, what two numbers that are the same multiply to make 49? Well, that's just 7. So that's why root 7 squared is 7. But what happens if you have a harder question, like root x to the power of 6? The 6 does not just cancel out with a square root. It's a little bit more difficult than that. There is a trick that I can show you, but let's go through the understanding of why we can use that trick in the first place. So I'll rub this out so I have a bit more space. All right, what I'm going to go ahead and do is expand root x to the power of 6. Let's go ahead and expand that. So essentially what I've got here is root x multiplied by itself 6 times. So I'm going to write that. Root x times 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 root x. So I've got 6 root x's all being multiplied together. That is the expanded form of root x to the power of 6. Now, what I'm going to go ahead and do is use our knowledge of what happens when you square something and then square root something. I'm going to use that knowledge to my advantage and group these terms here in pairs. So let's go ahead and do that. What I've done is I've grouped 2 root x's together in pairs, basically. So I've got 3 groups. That's what I've got. I've got 3 groups of root x times root x. Now, underneath each bracket, I can simplify in what's in those brackets. Well, root x times root x, well, that's just root x squared. And the same goes with the other brackets. Simplified, root x times root x is root x squared. So I've got 3 lots of root x squared all being multiplied by each other. Well, let's use that knowledge, like I said before, of what happens when you square something and square root something. You end up with just x. So that's the answer to that. Times x again, times x again. So I've got x times x times x. If I've just got x times x times x, we can simplify that to x to the power of 3, because there are 3 x's being multiplied together. So let's have a look at how we got from our original answer, sorry, our original question. How did we get from there to here? And is there a trick we can do? Well, the ultimate trick is that whenever you have a term being raised to the power of an even number, like 6 or 4 or even 2, the trick is to remove the square root sign. So we remove the square root, this is gone in our answer, and we just halve this number. So look at our answer here down below, x cubed. We've halved the even number we had in our original question, so half of 6 is 3, and we have removed the square root sign. Done. That is the trick for simplifying terms with even powers and a square root sign. That's the trick. Just halve the power and remove the square root sign. Done. Now, it gets a little bit harder again when you have something like root x to the power of 5. With root x to the power of 5, it's not as easy as just halving 5, because that's not going to be helpful for us. There's one more little trick we can do. But I'm going to show you the understanding part. Let me go ahead and shrink up my working out here. I'll just put that to the side there. All right. Let's go ahead and do exactly the same thing with our second question. I'm going to expand root x to the power of 5. Let's go ahead and expand. So, root x times root x times root x times root x times root x again. Alright, I've just expanded root x to the power of 5. Let's go ahead again and group two lots of root x's together. Now, I can't do the last one because it's on its own. So we're going to leave that for now. That's just going to stay there on its own. But I've got two pairs of root x times root x. This is one pair, and this is the other pair. I'm going to go ahead and simplify again what root x times root x is. Well, that's just root x squared multiplied by root x squared again, right? So that simplifies to that, and that simplifies to that. And I've got now, at the very end, times root x. All I've done is carried that root x down. So I've got root x squared times root x squared times root x. Okay, again, we can simplify what root x squared is. We know that. The answer will just be x. So x times x again times root x. We can't do anything with root x. And all that's left over is x times x. That's just going to be x squared. And then times root x on the end. And using mathematical convention, we don't need to use that times symbol, the multiplication symbol. We can remove it, and it just becomes x squared root x. So that's a little bit different to the way you deal with even powers. So in this case, 5 is odd. Now, what's the trick here? How did we go from root x to the power of 5 to our answer of x squared root x? What's the trick with odd numbers? Well, the trick is this. You pick out that number, whatever that number is, you subtract 1. So just subtract 1, that will end up as 4. And now you have an even number. So I'll write it again. So if you take away 1 from 5, you end up with, I'll just put it over here, you would end up with root x to the power of 4. And we know how to deal with even numbers now, right? This 4 is even, so all we need to do now is treat this as an even number. And what you do is you write the answer, which is x, and you just halve this power. So what's half of 4? Well, that's just 2. So your answer will be x to the power of 2, right? That's what we've got here in our answer, x to the power of 2. Now, remember how we just took 1 away? We took 1 away from our 5. We took 1. Well, what are we taking away? Well, we're taking away a whole root x, because we have 5 of them, and here we've only got 4. So we've taken away a whole root x. All we need to do is just, after we've done our even power, we just put it back. We put it back in our answer, which is right here, root x. So let's go through that one more time. I'll rub this out and I'll just explain it using words. So if you have an odd power, you take away 1. So it ends up with 4. So with an x to the power of 4, you just halve that number now. So half of 4 is 2. So that answer is going to be x squared. And then you put back that root x that you took away. Let's do a very quick example. I'm going to write it down the bottom. So let's do one more. Very quickly, let's do root a to the power of 7. All right, very quickly, what you would do is you would take away 1 from the 7. That becomes a to the 6. Then you halve that even number. That becomes a to the power of 3. So you write that. a to the power of 3, and you just put root a on the end because you took it away.